All right, so the first thing that I want to talk about is what exactly is Flutter? And to be able to answer this question, we first have to put ourselves into the mind app where instead of matching with other people, you match and you get to figure out what food you most eat. Super loves it, but there's just one problem. It's only on. So every other day he gets a question of when's it coming to Android? When is it coming to Android? It's coming to Android. And at some point, he finally has had enough and he decides to go and buy loads and loads of books, study Java, and finally he's able to have both of these buttons get a download on the App Store, on the Google Play and the App Store. Now, this is great, but for Bob, it means that when he has any updates that he wants to make to the app or any bug fixes, to push those both to the Play Store as well as the App Store. So and he has to maintain that's the amount of work that he used to have. But that's not all, because he gets complaints from users saying that, hey, in your app, some of the layouts look really weird. It doesn't look right. Like, why is this button like twice the size of everything else? What is wrong with your app? Now, this is only does he have to support a huge array of different screen sizes and aspect ratios for the iOS ecosystem, the iPads, the iPhones, the older iPhone, but he also now has a whole bunch of Android devices. Devices can be made by literally anybody. The number of screens is massive, and it's really hard to keep on top of what are all of in order to be able to design your app to look good on all of. Now, to add this question, screens everywhere. There's screen office, there's screens at the bus stop, there's screens, and they're all different aspect ratios and different screen sizes. Why can't we create something that can intelligently developers to design beautiful interfaces for all of these different types of screens? And this is exactly what Flutter is. That makes it easy for developers to design beautiful in all sorts of screen sizes and devices. It comes with a whole bunch of pre-built widgets that make it easy to lay out your app. Straightforward thing, laying out your app or with columns or stacks, and it borrows some of the concept where you can have things on things and margins. And what if you use and develop for almost any device? All that Flutter does is iOS web or desktop audio. And what Flutter will do, or onto that blank window it is rendered, and whatever animations or changes, it's all Flutter. So this means that instead of having to make Android apps the Android way, you can simply use a whole bunch of it from Flutter, such as a floating action or data, and you can simply put these into your app no matter what you're working on. And they've even designed widgets that look the platform. So for example, the alerts on your Android app, you also specify that if your app is being run on iOS, then like this, making your app look like it was created in native. This is how Flutter works. You get access to a whole bunch of widgets. See these widgets as Lego blocks, a beautiful app that can be deployed. Let's take a look at how easy it can be. I've created a blank app, and I'm going to go ahead and add app. And this is a pre-built widget, which is built by Flutter. As soon as I hit save, my app bar gets painted onto the screen. So I don't like it in blue. So let's customize it to change it to red. So now I add a color widget and color. So now let's add a text widget that adds a title to the app And just like Lego, I've plugged together all my widgets and I've managed to build my app bar in a matter of seconds. And there's loads of different widgets that are pre-built. For example, you wanted a floating action button. Then we create that widget and we can customize it by changing its properties, the background color, or what should go inside it. Piece by piece, widget by widget, you can and customize to my liking with very few code. Now, what if I wanted some functionality? Well, I can simply create a variable track of, say, the number of donuts that I've eaten in a day, and I can change my text field to embed a number variable in there. And then all that happens when the user presses on the red button, then it will increase the number of donuts I've eaten. And Flutter makes it incredibly easy to build a beautiful interface using these widgets, as well as allowing us to customize the widget. Finally, building functionality on top of those widgets is also adding a number of variables. And that we're going to dive into. So now that I've created my doc, the best part is I upload to all different devices without write the code or learn a new technology, a new skill or scratch. So when you're thinking of building a new project, why choose Flutter? What can you do? Well, one of the first reasons you might consider is that you'll end up with one code base to maintain, one place to debug, and one place to update. So one code base to rule them all? And this is a huge advantage compared to creating your apps natively. Say, creating your iOS apps in Swift and making your Android apps in Java and your web apps in JavaScript, and having all of these different places that you need to update and maintain, and it can get really messy. Whereas here, you only need to know one language, that's Dart, which is a powerful language that's actually quite easy to work with. But once you've learnt and understand how to use it, then you can use it to create your iOS apps, your Android apps, your web apps, and it means that you only have to get good at one thing instead of lots of different things. And if you've done any programming before, then you'll realize that Dart is actually very, very similar to a lot of modern object-oriented programming languages. It has a lot of features that other powerful languages will have, and it's been used internally at Google to build powerful tools such as Google AdWords and Google Fiber. And its use is only going to get bigger. Currently, we can already use Flutter and Dart to build iOS and Android mobile apps, but its applications go beyond that. You'll soon be able to use Hummingbird to create web applications, writing Dart code, and even use it to build applications that run on your desktop. Not only is there the advantage of maintaining and updating one code base, but Flutter allows you to use a very simple and flexible layout system to build beautiful user interfaces for whatever project you end up embarking on. And this is one of the biggest struggles that modern app developers have to deal with, because you might remember the iPhone 3G was first launched. There was just one screen size and one aspect ratio. It was a 3.5-inch screen. And it's crazy to think that it used to cost just $99. And now it costs something like $1 bajillion. But a whole family of devices. There's the iPad Pros, the iPads, the iPad Airs, the iPhones, and all of its little cousins and uncles and aunts and neighbors. And it's just a huge ecosystem of different screen sizes, different aspect ratios. And as a developer, you have to contend with all of this and to try and make the app look good on every single one of these screens. And it gets even worse when you start thinking about Android, because of the fact that Android is open source. So it means that literally anybody who wants to build a smartphone can use Android as the operating system. If you're building an Android app, it could be run on any sort of million types of devices with, again, different screen sizes, different aspect ratios. And you can see that even back in August 2014, there's too many different devices that were running Android, even for you to keep track of. So as a developer, if we want to lay out our screen to make the most of the screen real estate and making sure that the user actually has a good experience using our app. In order to do this, both on iOS and Android, we now use constraints. And constraints essentially get more complex as the number of elements grow on screen. So constraints can be really easy to do and do well if you only have 4 or 5 things on screen. But we're no longer in the 3.5-inch screen era anymore. And when we used to have a small screen, there's only so much that you can fit onto that screen. And this is the time when it made sense to use constraints. Few elements, little complexity. But as screens have gotten bigger and bigger and bigger, I'm pretty sure that the next phone will have no bezels whatsoever and it'll be the size of my face. But this also means that you can fit a lot more stuff onto that screen. So there's more elements, which means that constraining each of them in relation to each other gets more complex. And the more complexity there is, anything, means that it's harder to understand and it's harder to do a good job of creating beautiful user interfaces that have good user experience. So where does Flutter get its inspiration? Well, a lot of it comes from the web, because this is one place where they've actually had to adapt to various different sizes, because people pull up websites on mobile, on iPad, on tablets, on large desktop displays. So a lot of the things that have evolved in the web ecosystem have been really, really good at dealing with layout on different screen sizes. And through the use of things such as grids or columns or Bootstrap, we've developed really simple and elegant ways of laying out the user interface on a website. So why can't we do the same on mobile? And there's a lot of core concepts from web design that comes into development, and it allows you to make the use of rows, for example, stacking elements next to each other horizontally, or columns, items that need to stack vertically on the screen, or stacks, things that need to stack on top of each other, and then giving them padding or giving them margins or centering them, and having a whole bunch of these convenience widgets that make it easy to lay out your screen. Now, as if having a single code base to work with and an intuitive and beautiful way of laying out your app's user interface wasn't enough, there's also something called hot reload. When we're developing apps, one of the biggest pains is when you have to run the app, because often on iOS it can take anywhere between 10 and 30 seconds between saving your code, running your app, compiling it, and finally seeing it on screen. But when you're working in Flutter, as soon as you update your code and you hit save, your user interface will change in front of your eyes in a fraction of a second sometimes. And this leads to a very different way of designing the user interface. It's almost like you have a refresh button on a website. As soon as you change something, you hit save and you see the changes in your app, and then you iterate and you end up narrowing down on the design that you want because you get access to this super fast reload, and it makes it really fun and really easy to design beautiful interfaces. And you can see it in action here. Every single time that I hit save, see that down here you have the preparing hot reload, and instantly the UI updates. So I change the color, I hit save, the UI updates. And this is recorded in real time. There's no speeding up, there's no editing done here. It's just that fast. And it makes it a really fun experience to design a beautiful user interface. Now, the last thing I want to talk about is the fact that when you're working with Flutter, you get access to the original source code. Because Flutter is open source, it means that if you want to see how a button is implemented, you can simply just click on it and you'll see how they wrote the code to make it look the way it is, how to behave the way it is. And you can click on anything on the screen and you can see the original code that the team wrote in order for it to be the way it is. And it means that you can more easily understand how these widgets work. If you've been working on iOS development, you'll know that a lot of it is a mysterious box, because on iOS, a lot of the components are proprietary. How Apple implements a button or a slider is their secret sauce, essentially, and you don't get access to that. But on Flutter, you do. And what this means is that you'll be able to see how something in particular is implemented. And if you wanted to customize it, if you wanted to build entirely your own version of it, you can simply copy what they did for their version and update parts that you need to. So let's say that I don't want to use Flutter's standard floating action button anymore. I want to create my very own version. If we go ahead and take a look at it, we can see that it's built with this amount of elevation of the screen and a height and width of this size. And then we can see that once it's put together, it's based on something called a raw material button. So I'm going to go in here and I'm going to scrap their version of the floating action button, and I'm just going to build my very own raw material button. And my button is going to be customized the way that I want it to. So I want it to have a color that is maybe red instead of blue. So we'll change the colors to red. And when I hit save, you can see it performs hot red, and we end up with a red rectangle. Now I don't really want it to be a rectangle. I still quite like the rounded edges. So let's change its shape. Let's change it to a round rectangle. And I'm going to make its corners a little bit round. So I'm going to change the border radius to maybe, let's say, 50 pixels. And now when I hit save, you can see it's a lot rounder. Looks much more like the pill shape that I was looking for. So next, let's customize it a little bit more. I want it to be a little bit bigger. At the moment, it's really, really small. Let's make it a little bit taller and a little bit wider. So let's add some box constraints, and I'm going to change the height to, let's say, 50 pixels, and we'll make the width maybe 100. So now when I hit save, I've got the perfect button, and this is exactly the one that I want. And I've managed to customize it to exactly my liking based off looking at exactly how the Flutter team created the floating action button, and I just changed it to make it my own version. So there's a lot of really exciting things that you can do with Flutter. And in the coming lessons, we're going to be exploring and diving deep all of the cool things that you can do with Flutter and Dart. Before we get started installing Flutter, let's first go through what it is that you'll need in order to be able to work with Flutter and also run your apps on iOS and Android. Now, first things first, you're going to need a computer of some sort to be able to develop for Flutter. In order to create Flutter apps, you can do it. The next step of being able to develop Flutter apps requires a code editor to be able to create code so that we can build a Flutter app. And two tenders that you should consider are Android Studio and VS Code. And they're capable in terms of developing for Flutter. Now, personal preference aside, we're going to be using Android Studio for this course. And there's many things. It makes it simulator, it allows us to upgrade Android X or Jetpack, really, and down the line, even if you're using VS Code, there will be places where you'll need to use Android. So we might as well commit to one platform, and the one that we're in is Android. Now, if you have a preference for VS Code, you can use this course, but aware that when we're using certain specialized tools that have been developed for it, you might have to have a quick Google and see what you for VS Code. Now, of Android J and VS Code, I recommend using any other type of code to be able to hint and suggest code work to completion and to be able to work seamlessly with our emulators. Now, the next thing is testing our app. We can build it either as an Android app or as an app. Windows or a Mac user, you'll find it incredibly easy to run the Android or Flutter app. All you need is either a physical device, Android, an emulator, which I'm going to shortly show you how to download and how to set up, and a version of an Android phone that's going to run on your computer. Work just as well for the purposes of this course. Now, on the other counterpart of your Flutter app, things get a little bit more geeky. Apple has always been very sandboxed. So in order to develop an app and run it either on a physical iPhone device or on an iOS simulator, we'll need a Mac. And this is the part that's quite difficult to get around. The reason is something called code signing. This is done for security reasons, so that when people onto their iPhone, that there isn't something malicious on there. Every app that gets deployed onto a device requires a certificate issued, and to issue that certificate, you're going to need a Mac of some sort. Now, what about the simulator? Because similar to an Android emulator, it's also just a program that runs on your laptop or your desktop, and it simulates a real iPhone device. Now, in this case, you're not loading it onto a physical device, so you need a certificate for it, but the iOS simulator is a program that will only run on a Mac. So basically, you'll find that in order to work with the iOS app, to be able to put it onto the iOS App Store, you will make your life simply getting either a second-hand Mac if you don't have one, or you might just have to for a couple of days while you do your testing and while you upload your app to the App. For the most part, we're going to be doing our development using Flutter, and that is I do that on Windows, and it doesn't matter. But it's the test on iPad that's the key part. Now, Flutter has created some tools to make it easy. So, for example, here you can see that I'm running an app on the Android emulator, and inside the Flutter inspector, there's a platform that toggles the rendering to switch from Android to iOS, and you can see that top bar changes in appearance to show you roughly what it would look like if this was being on iOS. And this is great while you're testing and you don't want to have both emulator and an emulator up, or both an iPhone and an Android phone running the app at the same time. So this is a really neat trick that you'll surely find useful if you're working on Windows with emulator. Now, there's all tools like CodeMagic that you can continue to build, test, and deliver your Flutter app straight to the App Store. Again, building an iOS app without ever having tested it on a real to borrow one or get a secondhand one, it's worth doing just to ensure the experience and you've tested the app fully before you put it onto the App Store. So, as a summary, Android apps with Flutter, you Mac or download Android Studio and you get an Android emulator or a physical. For the iOS apps with Flutter, I recommend a Mac that you can with. You're going to be using Android Studio and you'll need an iOS simulator or physical device to be able to test your iOS apps. Now, in the coming lessons, we're going to be showing you step-by-step guidance on how to install Flutter on Android Studio and set everything up to ensure that you're ready to get started with development. So once you're ready, head over to the lesson and choose on which system you're running, Mac or PC. Now, in the last lesson, we covered flat buttons and the void callback that they expect. We also used the print function, gave it an input, or rather an argument. So in this lesson, I wanted to quickly cover Dart functions. So if you already know what an argument is, what return does, and what a function does, then feel free to skip this lesson and head over to the next one where we continue building out our Flutter app. But for those of you guys who are staying with me, functions, as you can see from the name, are there to give your app or you give your program some functionality, right? Now, in this lesson, I want to talk about functions in the most fundamental sense. And when we're using functions as programmers, fundamentally, we're trying to package bits of code together into a block and to call that block of code repeatedly, saving ourselves from typing the same code again and again and again. So, for example, if you had a little housekeeping robot, this guy, his name is Beep Bop, and he does a number of things, right? For example, he'll go and get you milk. Move 2 blocks, move up 4 blocks, then move right 2 blocks, get the milk, come back, and you have to specify all these instructions to him because the robot doesn't understand contextual information like go to the store and get me some. Now, if you had to do this day after day after day, every single time you wanted milk, your fingers would start hurting and you wouldn't want to keep typing out the same instructions, right? So what we can do instead is we can take these the robot understands and we can package it into a block. Now, many programming languages is represented by code that's inside a set of curly braces. Once we've got all our instructions inside our curly braces, we can give that name. And we called it get milk. Now, milk, I can tell that get milk, and it'll know what to do because it will find this function called get milk and look inside it to see what it do. It's like I'm creating a recipe. Right? It's like I want to bake cookies. So let me write down a recipe and get to my bot so that they can make it for me. And that recipe, or the name of the recipe, is basically the name of our function. In Dart, the way that you would create the function looks like this. Name, which is called get milk, and then we've got the curly braces, which is the thing that should happen when this function gets called. And then later on, actually need to use it, we will call the function or tell the computer to execute all of this by writing something like this, giving the name of the function. Now this is called a named function. Well, it makes sense because it's got a name, right? Identify it by. Now, if we dropped everything, namely the parentheses and the curly braces, this would become an anonymous function because it doesn't have a name. Are actually very useful. They allow us to other people do explicitly having to create this entire function and give it a name and its name. When we were coding up our on-prem, which void, it essentially wanted an anonymous function. We passed in gave it want to be when the button got pressed. This is all you need to know about functions so far to be able to understand our flat button. A little bit functions in more detail. We'll talk more about what goes in the inputs into the function, and also we'll talk about the return statement when we want a function to. But for now, it has a set of parentheses and a set of codes in the brace what should happen. So now that we're all caught, in the next lesson, we're going to get up and we're going to get two edges to actually make the app work. So for all of that and more, all right, so it's time to build a new app. And in this module, we're going to be building a quiz app where the user has to answer questions and we'll tell them how many they got right. And what? Now, by the end of the module, you're going to have an app that looks like this. It keeps track of the user's score and it lets them answer true and false questions. Even though the app looks simple, under the hood, we're going to be tackling some more intermediate programming concepts and also we can better structure our app. So as always, first things first, let's set the GitHub repository that we've got as the starting file. This is for our Quizlet app, and as always, we're going to copy the URL to Android Studio, and we're going to check out our project from version control, Git, and then we'll paste in the URL we got previously and clone it. And we're going to select no, as always. Instead, we're going to open it up where we saved it, which is inside my Android Studio projects. And we have to click on Get Dependencies in order for it to pull in all of our Flutter packages and set up our project for Flutter development. So as always, we have our main.dart, which contains all of the starting code. And in this case, actually, we haven't made any changes in the pub spec. We've actually left it as it is. And there's no resources that we've added, no images other than the app icons for the Android and iOS side. But the reason why we have the starting file for you is because we've actually gone ahead and created a very simple user interface. So once you've cloned the project, go ahead and run it, see what we've done. Once the app has run, this is what you should see. There is a background and there's some white text, and exactly as what it says, this is where it will go, and these are the true and false buttons that the user will declare their answer. And this is all that we've done. And it's a text widget and two flat button widgets, and they're of course embedded inside expanded widgets. They take up the right amount of space. Now, if you want to create this user interface clear yourself just to get extra practice, then feel free to create a new project. There's no images that you need and there's no changes in the pub spec. But given that we're going to learn quite a lot in this module, I thought it was a good idea that we gave you the starting components so that we spend a lot of time creating things and doing things that we already know how to do. So once you've viewed the code and seen how the widgets are set up, then pretty much you go to the next lesson and we're going to start building our scorekeeper. So all of that is the next lesson. All right, welcome to a new module, and in this module we're going to be making a beautiful BMI calculator. And in the process we're going to learn all about how to customize Flutter widgets so that it will look the way that we want it to, be able to implement our custom user interface designs. And by the end of the module we will have something that looks like this, a beautiful app that has custom components and styling, and it's going to help you calculate your BMI or your body mass index. The actual functionality of the app is incredibly simple. It's just a few lines of code, but the important thing is we're going to learn how to not just use the widgets that come out of the box that are made by the Flutter team, but we're also going to be building up and creating our very own custom widgets. Now, the design here is inspired by something I came across on Dribbble, which if you don't know about, it's a fantastic resource to get inspired by designs that are created by some of the world's top designers. And you can see incredibly innovative and beautiful user interfaces that you could think about implementing. And going through some of these websites, looking at what people are creating, it really makes you want to step out of the box and go beyond what Apple or Material Design provides you with, and to start experimenting and creating your own designs and your own branding and your own look and feel for your apps. And I'm going to show you in this module just how easy it is to do this using Flutter and Dart. So we're going to be implementing the design from Ribbon Vaults. And it looks really clean, really beautiful. And we're going to be doing our best to try and mimic the look and feel that we see here. Once you're ready, head over to the next lesson and download the skeleton so we can get started. Now, in the last lesson, we implemented the geolocator package to be able to fetch our current location, both for Android and iOS. And the code is super simple. It's basically a single line that fetches us the current location of the phone, depending on which location accuracy we want. However, there are two keywords that we're using in this code that comes from the documentation for the package that we've never really seen before. So in order to understand this, we have to first learn about asynchronous programming and why it's useful. Now, when we're writing code, there are lines of code which take a very short amount of time to execute. For example, if we wanted to run a print statement, the single line statement prints the word hello world into the console, and this takes fractions of a second to complete. But sometimes there are things that might take more time. For example, if we wanted to load a large image from the internet, even if we're doing it in a browser and if your internet is slower, you might see this painful loading of the image where it takes absolutely forever. And this is because there's a lot of data that we're trying to transfer through cables under, literally trying to get data. And the larger the amount of data, the longer time it takes for it to load. Now, consider if we made this function. It's a function that returns nothing, so it returns void, but it has a body that is composed of 3 steps or 3 things that it tries to do. And the first thing is to simply print hello moon to the console. This is pretty quick to execute, so we see the result pretty much immediately. Now, the next thing is to load an image from NASA of the moon. And I don't know how often you've done this, but they're huge, and that can take a long time. But because our function goes from top to bottom, our third step can't execute until the second step is done. So it's only once this image is loaded that the computer will actually run the very last statement, which is to print the words hello Jupiter into the console. Now, this behavior is what we would call synchronous. Everything happens in synchrony. Step 1 happens, then step 2 happens, and only once step 2 has concluded or finished and we've gotten the image back, does step 3 actually execute. Now, what would it look like if this was asynchronous? Well, step 1 would execute as usual, no changes there. But step 2, let's say that we're now loading our image master asynchronously. Well, in this case, while the image is loading and we're trying to wait on that data to come back, we can already execute step 3. And we don't have to wait for this to finish before we continue in our code. Now, why is this actually useful? I want you to imagine that come Monday, you're going to work and your boss tells you to get me 100 passport numbers. Get them to me right now. So you have to call up all of the customers one by one and ask them your passport number. So you have this checklist and you're going from the top to the bottom, one by one, calling up each customer. Now, it's not so straightforward, right? Very few people remember their passport numbers off the top of their head. So you have to start the call, ask them for their phone number, and then they have to rummage around their house and to actually find their passport to be able to give you that passport number. And this can take anywhere from a couple of seconds to a couple of minutes, depending on how well they've stashed away their passport. So what are you doing while all of that's happening? Let's represent this process using a graph. On the horizontal axis is time, and we have a couple of units of time. You can imagine each square as a second. Now, let's say that it only takes you maybe a second to ask that customer, hey, can you give me your passport number? So your job is kind of done now. Next step is waiting for the user to look for their passport and give you a number. And all of that time, you're just sitting there twiddling your thumbs on hold the call. And you're not really being productive right now, right? But once they've given you their passport number, you can finally spring into action again, and you can go call the next customer. And then the same process repeats on and on again until you've gotten to the end of that list and you've reached 100 customers. And nobody likes being on hold waiting on a call, right? And if that is the majority of your day, then it's not going to feel great. Now, you might have realized that there's a different way of doing this. You could, in fact, have just drafted individual emails. Say you wanted to keep it personal to be able to persuade your customers to give you their passport numbers. And you could have simply sent these emails off to all of your customers one by one. Now afterwards, this leaves you free to do any other task that you need to do, and as the replies come in, you can respond to them. So you no longer have to be there on the phone waiting for their response. Now, if we were to represent this in the same graphical style, then your day might look more like this. You send each customer an individual email, but it doesn't really matter how long it takes them to respond because you're able to continue on to the next task, send the next email or do the next thing, and they can take the time finding their passport, and only once they have their passport number do they respond to you and you get that email response back. And it's in that moment that you can actually act on it, and you don't have to be on hold waiting for them to fetch the information you need. So now your day looks more like this. You're using every chunk of the day doing something productive, and you're responding to the emails that you've sent out as and when the responses come in. So compare these two side by side, where in one case you're doing something, waiting, doing something, waiting, doing the next thing, waiting. Well, this is synchronous programming. Whereas in the other case, you're basically initiating a task, and only once that task is complete do you get notified and act on it. So this means that we're able to use only 5 units of time instead of 9 units of time to achieve the same thing. This is the difference between synchronous and asynchronous programming. Now, notice how this is all being done by one worker, you. It's not that you have 10 people trying to get 100 passport numbers from 100 customers. It's actually still one person doing that task, but it's just done more efficiently. You're letting the customer take their time finding those numbers and only getting your attention once they have the results. So let's build out a real example and take a look at what it would look like if we were to write it in code. Inside your Klima project, you're going to right click and you're going to create a new Dart file. And we're going to call this file simply just a scratch file. So it's going to be scratch.dart and it's going to be created inside your main project right here. Now, inside this file, this is completely separate from our project, and it lets us test out some Dart code. But unlike Dartpad, we're able to tap into all of the available Flutter and Dart libraries. Now, if you head over to this link, which will be in the course resources for this module, then you can see that there's a little bit of code that I've already written as some starting code for you. So go ahead and copy all of it and paste it into your scratch.dart. So all that we have here are 3 functions, task 1, task 2, and task 3, and they're called in sequence inside a function called perform tasks. And then in the main function, which is our entry point to this particular file, we call perform tasks. So right now you can run this scratch.dart without running any of the rest of our code by simply right clicking on the file and clicking on run scratch.dart. And you should see your console pop up. You can see that this is an isolated file that you can run without having to take all the time to load up the UI and build it onto an app. So this is where we're going to experiment with our Dart code. And you can see that as expected, all that happens is we print task 1 is complete, task 2 is complete, task 3 is complete. But the important thing to notice is that happen in sequence, because inside our method perform tasks, we said to do 1, then 2, then 3 in this order. These functions are getting called sequentially. Now let's say that task 2 was actually a really time-consuming task, like downloading a picture of the moon off the NASA's website. Well, let's simulate something taking a long time. We can create a new duration object called 3 seconds. And this is going to be equal to a new duration object. And here we can specify the amount of time. So microseconds, milliseconds, seconds, minutes, days. I don't want you guys to have to watch this video for days to be able to see this example. So we're going to keep it short to maybe, let's say, a delay of 3 seconds, right? So now to be able to enact 3-second duration delay, we're going to use a function called sleep. Now, the important thing about sleep is that this is a synchronous operation. So it will have to finish before the next line can be executed. And it takes a single input, which is a duration, and we can simply put our 3 seconds in here as the amount of time that we want to pause for. So when we call task 2, it will set a duration of 3 seconds and it will sleep our program for 3 seconds. And then, only then, do we get to print task 2 complete into the console. And because task 3 comes after task 2, then theoretically it should also come after 3 seconds delay. So now let's go ahead and click run again. So notice scratch.dart is currently selected as the thing that we're going to run. And now you can see task 1 complete, 1, 2, 3, task 2, task 3. So if you're watching this video on double speed or half speed, it might be a good time to actually put it back to normal speed, because I'm going to try and show you what actually happens with these delays. Let's just run that again and notice task 1, 1, 2, 3, task 2, task 3. So we know that each of these tasks, printing a single string into the console, basically takes a negligible amount of time. All that's causing the delay is this artificial delay that I've put in here, the sleep method, which comes from Dart.io. Now, because there are a lot of cases where things can take an unpredictable, but usually a long period of complete, such as downloading something or reading something from a file or even doing complex computations. It all takes a large amount of time. And what we don't want to happen is for everything else, every subsequent task, to be held off until this task is complete. So what if we could say that, you know what, let task 2 do its thing in the background, but continue forward and do the things that you can do right now. And once that long task is completed, well, then we'll deal with the results once that actually happens. In this case, we would be using an asynchronous method instead of a synchronous one. So let's simulate an asynchronous thing. We can do this by, instead of using sleep, we can use a method called future.delayed. So it has two inputs. One is a duration, and the second is a computation to run after the delay. This is what we need. So the first input is going to be a 3-second delay, and then I'm going to add a callback to specify what should happen after those 3 seconds are up. And it's namely creating this result and printing that task 2 is complete. So I'm going to cut and paste it into there. Now, the way that our code is going to run is, this is an asynchronous method. And we know it's an asynchronous method because it returns something called a future. So whenever you see future in the documentation, you'll know that the method is something that will happen asynchronously. And it will delay by 3 seconds, but it will allow other lines of the code to run if they can. Now, once these 3 seconds are up, then it triggers the computation in the callback. And in this case, it's to create the result, task 2 data, and to print task 2 complete. Now, if we run our code again, let's watch the console and see how it works this time. Remember that at the top here where we say perform tasks, I haven't changed that order at all. It's task 1 should perform, then task 2, then task 3 gets called. But now let's see what happens down here. Task 1, task 3 completes almost immediately, and then task 2 completes after a 3-second delay. So this is asynchronous programming action. We saw that because task 2 took a long time, we were waiting for it to happen, but we plowed ahead with the things that we can do right now. And once task 2 completed, it's then and only then does it actually get executed and printed into the console. Now, that's all very well and good for like downloading images from the internet or doing time-intensive tasks. Sometimes we need the results of the tasks to be able to continue to the next task. So for example, let's say that our task 3 actually required an input that comes from task 2. So let's change task 3 to take a string input that's called task 2 data. And then let's use that inside task 3. So task 3 complete with, and then we'll add our task 2 data inside this function. Now task 3 relies on something that comes from task 2. So that means we have to return something from task 2 to be able to do that. So let's output a string from task 2 instead of nothing. And we're going to output this result right here. Let's create a new string up here called result. And let's set it to nothing to begin with, but only after our asynchronous has delayed by 3 seconds. So let's say we're fetching some data from the internet. Only once that's completed do we assign result to a value. And finally, at the very end, do we actually return this result as the output of our task 2. So now that task has an output, we can assign that to equal a new string called task2result, going to equal to the output of task 2, and then we're going to use that inside task 3. So task2result is going to be the input for task 3. So the entire order of things is task will execute asynchronously, so it can take as long as it wants in the background. Now, once it's done though, it's going to assign some data to a string called result, and then it's going to print that it's completed and also output result. Now at this stage, we're going to take that result and bind it to a new string and then use that as the input for the next step, which is inside task 3. What do you think will happen given that we know that task 2 is asynchronous and it can complete at any time it wants, and our code will actually skip ahead to try and do the things at hand right now? So if we take a look at running our code, you can see that task 1 and task 3 complete almost immediately, and task 2 is taking its 3-second delay to complete. But because task 3 relies on some data from task 2, so if it executes immediately, then it won't actually have the information to hand. And so that's why we're getting task 3 complete with null at this point, because task 2 data isn't available until the task 2 completes. So how can we fix this? Well, we can make our code actually wait. So we know that this is an asynchronous method, and we allow other code to continue on and not have to wait for this to finish. But in this case, because task 3 relies on this second task to complete, what we can do is we can make code wait for it to complete before we call the next task. To do this, we can change it into a async method. So this is called a modifier, and we add it just before the code. By adding that async keyword, we can now have access to the keyword that's await, and we're going to put it right in front of task 2. So before we call task 2, we're going to wait for it to finish. Now inside task 2, we have to make some changes too. Instead of returning a string, we have to return something that's called a future. Now a future is something that will exist in the future. Right now, it's nothing because our task hasn't completed. But once our task has completed, then our future will be an actual thing, like an actual string or an actual integer. Now, we have to also mark this method as asynchronous to be able to say that we have to wait for this future.delayed method to complete before we can output our results. So now, with this updated code with our async and await, where we're waiting on the parts that need to complete in order to give an input to task 3, now if I hit play and run my code, you can see task 1 complete happens first, and then task 2 happens after a delay, and then finally task 3 happens using the data that comes back after task 2 is complete. Now, we've talked a lot about futures when we were writing our code in the demo. What exactly are futures? Well, they're kind of similar to receipts. Let me explain what I mean. Let's say that you go to the coffee shop and you order a cup of coffee. Now, at this point, you'll get a receipt with an order number, and you can go away and do something else or check Instagram or check Facebook while your coffee is made. You don't stand there waiting for it to be done. So then once the coffee is done, they'll shout for your order number 1, please come and collect. And now you'll show up and you can actually claim your coffee based on your order receipt. That receipt is the same as a future in Dart. It's not the actual thing that you want. It's just a promise that you will get something in the future. If you come from JavaScript and you've heard of promises, then it's exactly the same. It's something that doesn't exist right now, but after it's completed its thing, after it's gotten the image, or after it's downloaded the text, then your future will actually materialize into a real object, like a real string or a real integer. Now you can be more specific with your futures. You can specify that this is going to be a future string, or this is going to be a future integer. And we do that by using an angle bracket. So in this case, we can change our data type from just a generic dynamic future to something with a specific data type. So it could be a future string. So this means we're expecting a future string when we call this method task2. And right now, if I decide to comment out this line and try to print what task2 is equal to, then you can see that it's an instance of a future string. It's not an actual string yet. It's only once task2 is complete does that future string materialize and change into an actual string. Now, asynchronous programming is not the easiest concept to grasp, but I hope through reviewing and re-reviewing this lesson and also completing the modules that are ahead of you, where we're going to be using asynchronous awaits and futures in a lot more places, you're going to steadily get used to this idea of asynchronously doing something instead of doing everything in sequence. Synchronous programming, we're trying to be more efficient with our time, or with the computer's time, by trying to asynchronously do our tasks so that things don't necessarily happen in the order that we programmed it to, but we end up completing our tasks in the quickest way using this route. So this concept is going to come up again and again. Don't worry if this hasn't completely settled in your mind yet. We're going to be reviewing this a lot more in the future. But in the next lesson, we're going to get back to making our app and getting our location data as soon as we load up the screen. So for all of that and more, welcome to a really exciting module. In this module, we're going to be building a app. And not only is it going to look beautiful, but it's also going to be super powerful because we're going to power our messenger using Firebase Firestore. And this is what it'll look like by the time we're done. So it's got some beautiful animations, and we're going to be looking at how to implement animations in Flutter, but also we're going to be creating this beautiful messenger user interface. We're going to be able to set up a group chat, and we're also going to implement authentication and registration so the users will be able to register and log in so that they can chat with other users. First things first, as always, we're going to head over to the GitHub repository for Flutter, and we're going to clone that repository into our local system. So we're going to check out project from version control, and we're going to go ahead and clone this project. And once it's done, we'll open it up and get our dependencies. So if you take a look inside our lib folder, you'll see that we have a whole bunch of screens. Let's open all of them up. We've got our welcome screen, our login and registration screens, and finally we've got our chat screen where the chats are going to actually happen. Once you're all ready and set up, head over to the next lesson where we're going to get started. All right, guys, welcome back to a brand new module. And in this module, we're going to be building a to-do list app called Todoey. It's going to help us in the process of building it. We're going to learn all about state management. Now, this is what our app will look like. It's going to be pretty simple, but I think it's got a pretty beautiful interface. And it's going to allow us to add new tasks, to check off tasks, as well as to delete tasks from our to-do list. And in the process, we're going to be exploring what state is and how we use it in Flutter. And then we're going to be looking at various ways of managing state, as well as organizing the architecture of our app. So we're going to be looking at set state and stateful widgets, which we've already seen and we've come to love. But now in this module, we're going to take it one step further so that we'll know how to manage state for complex apps through the use of callbacks by learning about how to lift state, as well as learning about the provider package, which is what the Google Flutter recommends us to use when we're thinking about state management. And if you're wondering what is state and why do we have to manage it and exactly how do we do it, well, all of those questions will be answered very shortly in this module. So once you're ready, head over to the next lesson.